Recordings in progress. Evening, y'all. This is Foxtrot Platoon, evenings, weekends. This is Code Platoon. I'm Jordan. We're doing classes, basics, part 2. I would call this object-oriented programming. Classes are going to be the objects. This is going to be focused on Python. You can do this all in JavaScript. It works a little bit differently, but follows a lot of the same rules. You can do this in any language that's worth its salt. So let's get into it. One good way to think about classes is to think about them as, I guess, nouns. Nouns are easy to think about. That's why we are going to use dogs as these examples. Hope y'all can't hear him squeaking that, coincidentally. So we'll be setting classes as dogs, and we'll be doing things with these dogs to display how you can think about objects as physical things with class variables, instance variables, and instance / class, whatever you want to call them, functions. We'll be attaching functions to these classes. When you start to learn to code, when all y'all jumped into JavaScript for the first time, if that's what y'all started on, or Python, and you see your first object or you see your first dictionary, you start thinking, oh man, this is so cool. I can create things that make sense to me. This is probably not the first time many of you have created an object or dictionary and give it name, dog, type of animal, dog, like color, black, all that. But that has limitations. That's just a data type. You can't do anything real fancy with it. If we want to do functional programming, we could write functions that take in objects and dictionaries and do things with them, but that's not really associated with the animal of the dog, right? Dogs are more than their name, color, breed. Like they do other things like bark, and later on in here, change their hair color. Very important things for dogs to be able to do. And we're going to show you how to, I don't know, orient yourself around these objects. All right. Recap. In our previous lesson, we learned about classes and instances in Python. The key takeaways are classes can be thought of as templates for object or multiple objects, or an object or multiple objects to be instantiated from. Instance objects contain instance attributes and methods, which are copied from the class the object is instantiated from, and by default, the values set for the attributes defined in a class are the values an instance's attributes will initialize with. This behavior can be overridden using special init method. And this is the following of these key takeaways. Shouldn't be anything crazy new to y'all. What file do I want to call this real quick? We're going to get into something a little bit later, but for now, we'll just keep this simple. So let's just copy some of this, blast it all in here, but go line by line so we don't get lost. I am creating a class. This is how you do that in Python. We're going to call it dog. We're going to give it a type. Usually this is a reserved word. I wouldn't usually use the word type here. Setting to canine, and then name is going to be set to dog. I know that doesn't make a lot of sense, but it works for the example. When you create a dog, you instantiate it, it requires a new name. We're going to overwrite this. So this is an init function to instantiate, new objects. And we're going to say, hey, self, which is, hey, me, this instance of this variable, my name is going to be equal to whatever you pass in, which is name. So the way we create that, we say, hey, object, the main class is going to be dog. And we can set it to whatever variable we want. We're going to call this dog A, because that's easy to remember. We're not going to get confusing later. Dog class. And remember, when you instantiate this dog class, anything in here in this init bit is required. Self, you can, I don't want to say ignore it every time you see the word self, because you really have to think about when you see self, that's talking about that instance, not the object itself that we've constructed here, this structure, but the instance that is being created when you create a new dog. Self, we don't have to pass that in, that's assumed, but it does require a name. So to create a new dog, set a variable, class of dog, and give it a name. That's gonna create a new dog. I'm gonna pass it a name, just gonna assign it to that dog. Dog B is gonna be much the same. Don't take my word for it. We can test these things. So this is kind of something I want to talk about. I mentioned at the beginning of class, for those of you who were watching this recording and weren't here, I want to talk about shells just a little bit. One, because I think it's a confusing topic for a lot of you, and I've already seen issues with getting lost in the sauce on your shells. This bit down here, you'll see me doing silly nonsense like this and grep for, a dog here, what's going on? Oh, I don't, there we go. Oh, I found it. This right here in VS Code is your shell generally. Your terminal is what I would call it. And you can see my terminal is ZSH. That is Z shell. Z shell is a shell. Some of you, I doubt, but possibly might be in Bash, which is born again shell. Some of you might be in PowerShell, God forbid. A shell, which I had the definition pulled up. Oh my. Oh, Null messed me up. It's basically, I don't even like the definition. It's basically the way you're interacting with your OS, the way you're interacting with whatever it is you're interacting with on your machine. If you're not clicking and pointing with your click or your mouse, we're in Z shell. That allows us to use bash type commands. Z shell is an extension of born again shell, which is an extension of shell. And that lets us, look around, see things, and run Python. If I do this, this is saying, hey, within this shell I've got, take the Python executable and run this file with it. And that's going to do, things we're used to seeing. But what if I mess up and just do this? That doesn't look right. Oh, Ellis, let's look around. Oh no, where am I? It's CD? What? Nothing's working. Python? I don't even know what Python is here. Well, we're in a Python shell is what we're in, and you can see it right here. If I just invoke the word Python, it says, hey, you're in Python 3. Man, I know I'm not. That's an old Python that I should be using. I'm not pointing to the one I thought I was pointing to, but it tells you some things about, this Python version, the C-lang, all that jazz. Don't really care. But what's important is normally where I would run Python and then hand it a file, that is running the Python executable, opening a shell of Python, running the script through it, closing it down, and then you get the output. I don't have to do that. And it makes objects a little bit easier to understand or slash. This is another way to work with them. So while I'm walking through object-oriented programming, while you do this on your own, you've got a few different options for how you want to interact with these objects because they are instances. Working with them in a shell can make a little bit more sense to some people because you create them and they don't die immediately. Like we don't kill these dogs after we run this. They're still alive. When I run Python dog.py, it creates instances as it reads through this, right? It reads it top to bottom, gets to these lines, creates these dogs, runs these print statements, closes out, they're gone. If we want to work with these objects, we have to think about them in a script. We have to think about, well, I created dog A here. I printed something out. If I want to see more stuff about dog A, I'll have to, invoke it here. If I want to make any changes to dog A, I'll need to, do something like this. Stuff like that, and then see the output, which is fine. You'll see me kind of jump around between both. But again, it's reading it top to bottom. In this shell, we don't have to do that exactly. In this shell, as long as this shell is open, any objects I create are going to persist. And I'll kind of show you that. So just as you would import a file in from Python, I can import in this dog.py into this shell I've just created. It's always backwards than what I think. Import dog. I don't have to put .py because this is Python shell. It's looking for .py files. Import star. I'm just going to import everything. Notice I imported this file and it ran these two print statements. So it did run it in this shell, but more importantly, I think it created these dogs as well. Let's find out. Remember that? I created a new name. Buddy's still around. We could create a new dog in here, dog C, just as we've created these first ones here. Name it after my dog. There's a new dog. And we should be able to get an output like that. So I'm creating these objects in this shell, and they are alive as long as the shell is alive, and I can continue to interact with them. This is a way to interact with objects, or you can run through a script. I just trying to show you this kind of this tool that you maybe have not been using for development, which now kind of makes a little bit of sense when you're working with objects, because them persisting can be a way to interact with them that makes more sense to anyone. Who have I lost? Does anyone have questions about this Python shell? It's okay if you do. This is completely new kind of thing.
You just typed Python and hit enter just to go into the Python shell rather than put in the name of the Python file.
Correct. Yeah, I created a shell of Python agnostic of any Python files on my computer.
Sweet. I did this accidentally a couple of times and it screwed me up.
Yeah, I've seen a few of you do this. Don't freak out. You can get out of here. I think quit works. Oh, it tells you right there. I mean, if you mess up and you want out, this isn't Vim. It tries to help you get out of it. Use quit parentheses or control D in the file to exit. I think exit works. Oh yeah, exit even works. There's a lot of ways to get out of it. Don't lose your mind. But that is a Python shell. It tells you you're in a Python shell. That's a way to create and work with objects. If y'all hate that and don't want me to do that, I'll continue to run things to this file. But I think it's something that helped me a lot when I was kind of learning how this stuff works. Back to the lecture. So we've displayed some things. Created a dog, created two instances of dog. You can get their type and their names by invoking them like this. If you want to do that in this script and actually get output, you're going to need to wrap it in a print. But when you're within a Python shell, you don't have to write the word print. It'll just feed it back to you. I think there's one other interesting thing I want to do. Oh, keep in mind, you can up and down in here and repeat, previous things. Look at that. One last thing I wanted to show you. So dog B got recreated. Before we were doing dog B.name. But if I just call dog B, it points, I mean, it's basically the pointer. This is where it's saved in the old computer. So that's showing you that is a object that has been instantiated. You can take a look at it. If you want more than that, we're gonna have to, work with it. But this is useful information, not the exact point here. I'm not gonna go find this information, but this shows you, hey, this points to something that's been created, and it's not going away until we close out this instance. All right, class method syntax. So I've been using the word function. What I mean is method, which is more specific. As we learned in the previous lesson, methods are defined using the reserved keyword def, define. When writing your own method, as opposed to calling a special built-in method, you can name your method whatever you want, as long as the name you use is not a reserved keyword. Following the name is a set of parentheses in which you include any parameters. We know how to do this. we're junior Python developers. So cool, no spoilers. So we got class dog. We've got a, what do we like to call it? Class method syntax. This is a class method, sorry. I jump around languages a lot and I have to remind myself what everything's called. This is going to be your class method. This is to update color. So like I said before, these aren't just variables. You can have methods attached to them to allow you to interact with these objects via methods, which is a little bit better than just resetting, names or variables, right? If I wanted to update, a dog's color from black to brown, that's easy peasy. What if I wanted to update the dog's birthday, if its birthday is within this day stretch, and I also need to know if the dog's still, in the pound or whatever you want to think about it. Like if we're starting to do more complicated work with these objects, you're going to want methods real soon. And you don't want these methods existing outside of the objects because that doesn't make any sense. They should exist here with the dog. So we're going to attach this with the dog. So instantiate this dog, just dog parentheses. Notice this new class doesn't have instance variables. We don't have to instantiate it with any variables whatsoever. We can just invoke dog. If you were to run dog.update color, you get this type error because, like all methods, if you've got parameters that need to be met, it's going to blow up on you. But if you want to update the dog color to black, this is how you have to do it. So let's just prove that this works. Doing this outside of the shell. Should have done that a smarter way. All right, look, we're back outside the shell. Let's run this Python dog.py. Oh, oopsie doopsie. What did I do?
I think you have to give it a color when you create it.
Sure
Initially in
do.
your-
That's right. So you can create this dog. All right, I read a little fast. You can create this dog without giving it a color. However, when we go to try to run this method, it can't update color because there is no color. So really, it would make more sense for this class of dog to, have this built in so you can't make a mistake. Something like that. Anyhow, check it out. We printed the dog's color. It was brown. We ran this method update color, which called this, updated the color, took the color, set self.color to the new color. Printed again, it was black. Does everyone follow that logic? Sweet. Now we're going to get into something that's confusing sometimes for different developers. And I say that because I had to update this lecture. Modifying class instant attributes through methods. So we've got class variables and we got instance variables. There are times where something should be a class variable and there are times when it should be an instance variable. Generally, this is bad practice. I wouldn't want to see, color of all dogs to be brown. I kind of want to see that specific, to the dog itself. Class variables are going to be things that are true for all of the instances, and things that are going to change from instance to instance, those belong down here as an instance variable. That all kind of says what I just said. Basically, when you go to reference this dog, it's not going to know the difference between if I had two different colors, like I did here. Notice I set a class, or rather, if I had a class variable of color and an instance variable color, or whichever, it doesn't really matter. The instance doesn't know what's a class variable and what's an instance variable. It only knows the variables it has. So you need to be careful about which ones you specify, because you can run into some trouble, as we'll see here. All right. Line by line, so we don't get lost. Class dog, species canine, color brown. These are class variables. When you create a new dog, we need to give it a name and a breed. These are going to be our instance variables. We've still got this method, a new one though, update breed. Everything looks good. And now we're going to create dog C, dog D. Name Carl, breed Cocker Spaniel. One thing I kind of want to point out, you can do this if you want to. That there's reasons why you want to do that, because positional arguments are great if you got like 1 or 2. But what if we did stuff like, you know, age and I don't know, size, and what's something else dogs have? Tail, like if it's docked or not. So right, that's great. This is not that complicated, but now we have to start doing stuff like, you know, age, size, tail, and now that means these arguments are going to become probably an integer or two, and then large, and then no. This doesn't make a lot of sense, and it might get a little weird when you start building this out. It'd be really easy to get something out of position here. Like, what if I put these in the wrong order and did large, and this one was 2, and I go to plug that in, and it's just going to mess everything up, because now my age and my size are going to be backwards, and that's an easy mistake to make, right? You could see how you can make that mistake when you're just listing things out and you have to go and reference. Well, you won't get into that problem, and the position does not matter if you just set them like this. This can help you out a lot. I just want to point that out. I don't know if y'all had a chance to see that or not. Does that make sense to everyone? Do y'all see what I'm talking about with the specifying the argument? You'll see the benefit in that. Cool. Do what you want to do. It doesn't matter to me, but I just want y'all to know that that is an option, and you will see that. Oh yeah, that wasn't the right way to split that. Anyways, all right. Let's run this. Cool, it's doing as we expect. So we've instantiated dog C, dog D. If we want to check the breeds are as we expect. Dog C should be a Cocker Spaniel, and then we should see Dachshund. Dachshund. Yep, that's what we wanted to see. And then we print their colors, we should see brown and brown. Nothing crazy there. We haven't mixed anything up just yet. Using this method, reference this, right? It's going to be update breed. It's going to be referring to the instance itself, and it needs a breed, at which point it will set itself's breed to whatever breed it receives. So if I wanted to change, I made a mistake. I said, dog C is like, oh, that's not a Cocker Spaniel. That's I say Canaan. Is that right? I don't know what this is. It's like a big old canary mastiff is what I think, but I don't think that's the right thing. So we update the breed and we run it again. We should see this kind of output. And then obviously dog D didn't change at all. Oopsies, let's wrap these in prints. If y'all haven't seen this before, and if you ever see me do something quickly, feel free to speak up. I'm holding the control key so that I can type on multiple lines at one time. That's just a VS Code thing that I remember. Don't ask me a bunch of shortcuts for VS Code. I don't use it daily, but there are some things I do use. Like holding Option and moving stuff up and down, or holding Shift and Option and duplicating things. Let's run this. Cool. Notice we updated dog C's breed. We got this output. Dog D did not change because we only updated the breed on dog C. So the following can get messed up a lot, and you'll see some stuff that doesn't I don't know, it can mess you up. You'll see things that are not consistent when you go to try updating a class variable directly. So remember, we've got color set as a class variable. This goes to all the different, this is the same for all the instances. One would think that if I were to update this color, it would spread out and go to all the other dogs. That's not exactly what we're going to see, though. Notice I'm taking dog C and I'm changing its color to brindle. Adjusting a class variable. Naughty, naughty. Don't do that. Really should have updated this to make it easier for myself. There we go. Let's see what we get. Dog C's color changed to brindle. Don't know what that color is. What, this is like a Cocker Spaniel. Aren't they called brindles? Dog C's color is still brown. What happened here? Does anyone know what happened here? I mean, it's obvious. I updated the class variable, right? Is that what happened?
Yeah, but it's only for that object.
That's right. How come though? This is a class variable I updated.
Because you've already instantiated the object. So you have
True
to
that.
re-instantiate it.
Yeah, I didn't make an update to all the dogs. I didn't make an update to the dog object. What it really did, what I actually did here under the hood is I created a new instance variable called color, and I rewrote over this basically. So it didn't change this exactly. Instead, you can't one line on this. It blew that away and moved it down here. That's all I did for that one instance object. Any other dogs are still going to be, they're still going to be matched to, they're still going to have that brown color. But for this one in particular, I overwrote the class variable with my new instance variable.
Question, if you left line 8 like it was and passed in a different color, what would happen?
I mean, that's what we did here, right?
Yeah, but before it was a class variable.
Sure.
But if you moved it down with self, will it change anything or it will behave the same?
It should behave exactly the same if we create a new dog, I think. And it does. You can set, just because it's in here, by the way, does not necessarily mean, and this is kind of like, why would you do that? I don't know, I'm just showing you. We could set it to something that, like, we could set it to brown here so that we don't have to pass in an instance. This might be the way I kind of prefer to see it. Truly and honestly, color belongs down here, but if all of your dogs were brown, I would still rather see it as an instance variable. This is Jordan talking. This is not like what the Pi manual says. If you're going to be changing it, I like to see it here. I don't want to see it up here. This kind of stuff, you should not be changing much unless you're planning to change it for all of them. And I'll show you how to do that now. Breed is defined as instance variable. Modifying the value only affects the instance. Yep. Color is a class variable. We create a new instance variable with the same name as the class variable, but only for that one instance. This is why it's important to understand the difference between them. Kinda. You could probably ignore what just happened here, but I don't want you to. I want you all to understand what occurred here, because when you work with objects, modifying these can get you in trouble. If I wanted to directly mutate this and then create a dog later, you're gonna have to understand that it's going to take on these mutated variables. So if you wanted to, so what I wanted to display is jacking with the class variable and getting the desired output. So dog, species, canine, color, brown. Again, not a good idea, but we're just showing off. Using the class method decorator, I could change the colors by saying, hey, this is for the class itself. And this is going to be all the instances of this class. Take a color, and then you would set it like this. This is how you change class variables for all of your instantiated objects. Let's test it and then look at it. So we've set our two dogs just like before, didn't change any of that. And when we print them, yep, they're both brown. Looks good. Dog C dot change color, pink. Now again, this is dogs. This isn't the way I'd want to see this done necessarily. I'd rather the name be like change all, dogs, colors, or something like that, just so you don't get it confused. But this will absolutely change both of these dogs to pink. If you were me, if I were you, I would do it this way and update the object directly, saying, I don't care. Yeah, I know dog C is an instance, and I know I could, reference it from here. But what I really want to do is change all the dogs to pink. And now you'll see both of the dogs kind of get outputted as a pink in this instance. Is that really the best way to prove that, though? Look at that. Okay, so it does, in fact, work, right? Keep in mind, this wasn't a very good test because I didn't change it from here to here. But since I've changed it now, you can see it did update all of these dogs after they were instantiated up here. Do we all follow? Cool. Been going about 45 minutes. I'm going to wrap this up with some quick test-driven development. I talked about it a little bit at the end of class, and I say I talked about it. I posted in Slack about what I was doing. I took, I basically committed a PR and showed off, look what I did. But I'd really like to show y'all real time how I would use test-driven development, how I write tests in Python to test these kind of things. You don't have to do this in class today, but a lot of times we'll say, hey, make sure you write good tests. These aren't really tests. In the real world, we're not putting print statements at the bottom of our Python and like, oh, it's just a test, ignore it. That's silliness. You're not turning this in. You wouldn't turn this in for a job interview. They'd think you're silly. They would expect you to have, actual tests written. And I can show you how to do that. So in here, and you know what? Why not? We'll open up the tree. So this is our folder, and we've got this dog.py. If I were to move these around a little bit, I would make a folder called models. And I'd probably put dog in models. Models being, the word gets thrown around a lot, but for at this level of Python, you can think of objects as models. After that, I would create a directory called unit tests. This is where we'll put our tests. So not to cheat, we'll leave some of this. Get rid of that. I don't really want that. See that here. Get there. All right, cool. So think about it this way. Like you're new at the job. I want you to welcome to, Jordan's dog haven. We take dogs and we need you to check them in, get them in our system, figure out what kind of, animal they are, get them processed. And I need some Python code to kind of keep track of all that. I want tests for it. Or if I say I don't want tests for it, doesn't matter. You're allowed to do whatever you want. You're working part-time at the, my dog daycare. So you probably don't have a lot of supervision. What you should do is start with your tests. So ignore this for now. Don't start with dog.py. Don't jump into code as soon as, you start thinking about it, because that way lies madness. You're going to start coding yourself into a hole and not really thinking about everything that you need. You should really be thinking about your tests first. So did that get moved to where I thought it would? Why is... Oh, I see what happened. Interesting. So let's go into unit tests first. And then we're not going to have... Actually, this is what we're going to do. I'm just going to show you what I'm going to do. I'm going to create a new file. I'm going to call this dog.spec.py. I call it this because the Python unit test module is going to be looking for files that end with spec, and those will be the tests. And it will know what to do with those. Let's open this up now. Empty file. Some things we need. Import unit tests. And then from models, you could import everything if you want to not be fancy about it. Let's be specific about it and import a dog object from there. And I know this seems like, Jordan, I can't remember all this. You do it the same way every time. I'm looking at an example because I don't know it on the top of my head. Let's call this test dog using the unit test module. I know I misspelled that. And you might notice we're creating our own class here. I want to make a test dog. We'll actually call it dog A. From dog, we're going to just instantiate a dog. At the bottom of our file, because we want this to run when it's run. I think that's supposed to be indented. Yeah, probably. No, just like that. This will basically shows the file how to be run. This looks like a bunch of junk and boilerplate, and it kind of is. But it's at this point where we're actually going to start. So without ever looking at dog.py, which is our model, which is our actual no shit code, that's what the dog is going to be created from. We're thinking about the tests first, because I want to know what it looks like when it works and how I would write my tests out for that. So I think a dog should have, at a minimum, a breed, an age, and I don't know, what's a good Boolean for them? Let's say like active and inactive. Maybe they're actively a customer and then they haven't come in a while, so let's call them inactive. Does that sound good, I think? So we'll make an example dog. This one will be Squid. He's going to be 7, and he's going to be active. Or no, sorry. I want it to be a Boolean. True. With that said, I want tests to verify that this works as intended. So some simple tests. How do we verify that this showed up exactly like we wanted, you know, kind of how we expected. These are going to be some really dummy tests, like almost smoke test level stuff. Let's test age. I can put dog up here. I can put dog down here. It doesn't matter. Actually, let's put it down here because it'll make more sense for this specific thing. Self, assert. So there's a ton of things we get out of unit test. Some of the more basic ones is what I'm going to be talking about here. Assert equal. I want to see that dog a dot age is going to be equal to. No, I think I just need to. Going crazy with this. Sorry. I just want it to be 7. So this should create a dog using our dog instance and test it. The age ought to equal to 7. If it doesn't, the test is going to fail. If it does, the test will pass. So reminder, we haven't done anything with dogs yet, but I've already decided, hey, it's going to be called dog, and it should be able to have ages. I want to verify that if I create a dog, I should be able to get an age from it. Seems like simple, dumb, you know, kind of thing I'm doing here, but it gets a little bit more complicated as we add stuff. So at a bare minimum, we know, looking at our dog spec, that we need an age. And I can probably do away with all those other things for right now. Straight up, just age. Good. So we've got dogs that now have ages, I think. How do we test this? Well, oh, goodness gracious. Don't do this to me, GitHub. Am I where I want to be? I think so. Python 3, take a module, unit test, which is our unit test module, not this folder. Discover unit tests, which is my folder here. So we're saying Python 3, use a module, use the unit test module. I want you to discover / look in the unit tests folder for anything called something spec.py and run it. Oh, I think I put it in the wrong spot. Right. We did run a test though. One test ran. The error we got is cannot import dog from models, unknown location. What happened here? Oh, I know exactly what happened here. We didn't import it right. So we need to go into models in the dog folder, or sorry, the dog file. Let's run this again. Everything was okay. That test passed. So I didn't start here. I didn't create a dog object. I didn't have to, sit here and think about all the things that a dog needs to have. I started here in the spec. And guess what? I've got a test right now that I can turn in and say, hey, my dog tests are working, that my tests are passing, my smoke test is working. What else should a dog have? We'll move a little bit faster with it. Test name, right? Name. I want to verify this dog has a name. And this is why you might want to keep these out here sometimes, because as we start building upon these, we don't want to have to make changes to every single one. This one's going to be squid, and he's going to be 7. And we're going to be referencing this same dog in all of our tests, so we're not going to put it up in here. But you could create a new dog in each one of these tests to test specific things. Test name, test name, test name. That failed. takes 2 positional arguments, but 3 were given. Well, we didn't update dog. So I wrote a new test saying, hey, my dog should be able to accept a name. And it's saying, oh, well, this only, it only accepts 2 positional arguments. You gave me 3. That's right. Dog, only has age. So let's put name here. Did I do it in the right order? Or did it? Dog A is not defined. Yes, it is. It should be defined. Maybe you can't put that here. Give me a second, y'all. Oh, I think I know what I have to do. Never code on the fly when you're recording. Everything's going to go to crap. Dog object has no object name. Let's make sure everything is saved as we expect. Oh man, what's going on?
On your dog.py file, do you have to have self.name?
Yeah, I do. Look at that. I didn't even follow what I was supposed to be doing. Running. Great. We have passing tests. As we build these out, obviously these are very simple, easy things to test for. But this looks kind of nice, right? I've got actual tests going off. These can get more complicated as we do more complicated things. Like I want to see the color, then I want to change the color, then I want to check the color, and then I want to, verify the colors within these color variables. I can do more complex things like that. But again, I'm writing these tests out as I go. And starting here, you'll start to get kind of fast at these when you're not recording yourself in front of a class. And to run your tests, you just have to invoke this every time, but that's a lot of words, right? I have a solution. So if you ever find yourself doing something multiple times all the time, especially in coding, especially when we get to Django, we're going to be typing out like Django dash m dash, app, new app, start app, run app, all these things. We have a lot of options available to us. Basically, we can script things out. We can set aliases. We can, just press up and down on the arrow key, go find it. What I'm suggesting is we create something a little quirky. I'm going to create a file called run tests. This is going to be regular old scripting. This is going to be bash scripting, or it's going to work in Z shell. So just like I ran this, I'm just going to plug this into this file. This isn't a Python file. This is a regular old whatever file. It's really nothing right now. So I can just slap this bad boy right there. How is the computer going to know what to do? This is called a shebang. This is saying, hey, go get bash. So when this file is run, I tell the computer, hey, execute this file, line 1. It goes, oh, you want me to do it in bash? Okay. And then it will run this in bash. The last thing we have to do, notice if y'all's colors are set up like mine, this should turn up white. We can't invoke this yet. Reason being, this is read, write, read, and read for the user, the group, everybody. We need this to be an X. We need to be this, needs to be executable. Change mode of operation. Modify the operation mode plus X, which is executable. Run tests. It's red now. And we can invoke it just like that. I'm saying, hey, run something at this level, run tests, and it's running it for us like that. So that's a lot easier than, typing out, oh, goodness gracious, Python, all that jazz. Do we agree that's faster? Anyone dislike that? Don't worry, I'm going to make it even cooler. This is a tool called ENTR. There are many tools like it. There are a lot of ones available for specific languages, specific frameworks. things like that. I like this one. All it does is, hey, when a file changes, when X changes, do Y. Very simple. I can use this for any test I write for any language whatsoever. Looks a little complicated. It's not. You just have to know the syntax for it. The syntax for this, we're going to ls into models star.py. So anything in models that is something.py is what we're watching. We're going to pipe that into entr. S is basically run some script, run this basic, command, and run tests. It's stuck. What's going on? Well, let's find out. What if I change something to dog.py? Self dot, I don't know, color. Don't save yet. Save. Oh no, we're failing tests. And it tells us immediately when I save. Missing positional argument, color. Well, that's no good. Let's go fix that. Brown. And I'll show you how to set up tests properly once this should have been part of it. Notice this isn't going to change because we're really just watching models.py, but notice we're not failing tests anymore. That's cool. That sucks. What if I want it to run on my tests also? Well, don't you all worry. ls. Okay, well, I've even got it written out for you. ls star/star.py, meaning watch models, watch unit tests, anything in any of these folders at any of these levels here that end with pi. If they change, I want you to run the tests again. So we can make changes to our tests as well. Look at that. We've got a failed test here. Dog spec line 13, dog spec line 13, missing positional argument. Oopsie doopsie, purple. I run it. Oh, we ran 2 tests. We're okay. With this setup like this, which I know it seems like a lot of setup, I can give you a file, basically the run test file that I normally would hand out. Looks something like this. Don't say I never gave you anything. This has notes in here that tells you how to run it so you don't have to remember. You can use this run test executable file here forever or as much as you want during class. I'm not going to be hopping into your classes and expecting you guys to be using this, but tell me that this is not kind of cool. Does anyone like see value in this? No value in this? Wasting y'all's time? At least somebody, I want y'all to think that it's cool to have tests running themselves as you're writing your code in either tests or your spec files, right? Somebody's, yep, I see a thumbs up. That's right. This is cool stuff. We're having fun. I can give refreshers on this under Slack channel. I'm going to give you these files. So pretty much all you'd have to do if you want to start your, I don't know, your assignments today, you could set up your environment just like mine, have a unit tests folder, have a models folder, put your tests in your test folder, put your models in your model folder, and then have a run test file with exact same stuff as mine. And you don't have to remember these complex commands if you don't want to. You just copy paste them, whichever one you want to do. You want to just watch the models, you want to watch the Python files, great. Put it in here and code away, do whatever you want. The only thing you'll have to restart this for is if you add new files. If I added a cat.py, I'm probably gonna have to restart the shell because it's not smart enough to pick up on new files piped into it. This command here said all the files that exist right now, watch those. If you add a new file, it's not going to pick those up. It's a running, this is a shell also. I started a bash shell when I started this. ENTR is going to be reading that and feeding it. It's okay if you don't understand everything I'm doing right here. But if you're interested in it and you don't understand it, you want to understand it more, please ask me. It would be so awesome if one of y'all got to an interview and they said, all right, I need you to do something in Python. You said, no problem. Let me just set this up. And all right, I'm ready. And they're like, what are you doing? Like, oh, I got my tests. I'm gonna write in my tests folder what it is you want to do, and then I'll code it out. I don't have to pseudocode. I don't have to plan it out. I don't have to use a whiteboard and explain the things that I'm doing. I don't have to write tests. I don't have to write edge cases. It's all right here as I go, as I'm thinking about it. I can't speak for, you know, the people that would be interviewing you in the future, but if you did that in front of me, holy crap, I would be so impressed if a brand new developer walked in and was doing stuff like this. It's not that complicated, and if you do it a few times, you get used to doing it, and it'll just be second nature. I'm starting to rant as usual, but this is important to me, and I do care about it, so that's why I'm making a big deal about it. Any questions as we wrap up this lecture? Cool beans.